Oh,
Okay, we're live. Let me share this copy.
oh, it's showing the HUD for some reason.
Is it?
Yeah.
Would you like to use my camera? Yes, it is.
Yeah.
So grab my camera. Just change
Yeah,
cameras.
on
It's
this
going
one.
to work.
Yeah.
I'm not going to change the live link.
Yeah, we're not gonna change the link. We're just gonna change it.
Let me send an email to.
Is it okay for me to unplug this for a second?
Yes.
All right. Yeah, once.
Let me.
All right. I did not see. Actually saw her the other day. That Steven tour is right below Tiger Labs.
Okay.
I saw. I was like, yeah, sorry. We never really had like too much conversation. So kind of like awkward, but so yeah. Good for her. Yeah, that's awesome.
No, I'm going to post on new notes. I'm going to post on our meetup group. Does everyone have access to the meetup group? Hey, good news. I have a bunch of people asking for the YouTube live link. It's going to work. Emma, is
Yes,
it working?
it is working.
Fantastic. Let me
We
grab
are live and running.
Okay. It's working. You're right. Just a second. Don't click. Stop click. It's my fault. It's my fault. Get shareable link. Anyone can view. But I'm going to put anyone can. There it is. It's my bad. Anyone can view. Let's see if you can make changes. All right, refresh. There's a new collab link. Right back. See if you can access that.
Clutter.
Thank you. Just wanted to check. Set, my son is using this one, but you want to sit over here. You don't need the chair right now.
Where?
It should be in the meetup, I think.
In the comments?
Probably, yeah, the very bottom.
Got it. Yeah. I was looking at the top. Thank you. Got it. Thanks.
Okay, has everyone got a chance to access, was able to access the collab that was posted on the Meetup group? Now let's see if you can create your own collab. Click File and click Save a Copy in Drive. See if that works. It did? Fantastic. So you now have your own copy that you can edit. Close mine because it's going to be exactly the same, and you have this copy forever. And basically, you can start accessing the databases that you want. You already have a code here, pre-code for it. Okay. Okay. That's our fourth class. Let me see if I got the correct one. That's it. Okay. So, how are you? A lot of new faces today. So, what I'm going to do today is this. We have been using this database. This is a Black Friday database. And we had a business question beforehand. We were assuming that we are in a marketing, in a company that has a marketing department, and Black Friday is approaching. So you want to know, okay, how are we going to market our products? That's our main question. And we have the data from previous years. So this is the data from previous years. Let me. Now, this is an example that you can find here, Kaggle.com. For those who don't know Kaggle, this is a very, very, very good resources for databases, for business cases, and for challenges as well. So if you want to get into the data science world, I highly recommend Kaggle. They're not sponsoring this, but they're very good. Well, they are because of the database that they're using. Okay, the reference, what we have gone through this the past 3 classes, so I'm going to go quickly through everything that we've done, and we're going to do the next steps. But of course, that as we do have new people here, I'm going to, please forgive me, but I'm going to go through some details again, important things again, and it is good to consolidate. By the way, next Wednesday, we are going to start Machine Learning 102, correct?
Thursday,
Thursday, yeah.
quinta-feira.
Quinta.
Quinta.
Okay, so next Tuesday. No, Thursday. Okay. Well, I don't know because here's Adam. Adam is going to teach Machine Learning 102. Maybe the first class. The first in the second class, I might teach. That's something that we're going to discuss. But he's the teacher. He's the official teacher. Machine learning 102.
Should it be at the same time?
Yes, but I have to check the date because I don't remember what the Kelsey put. Is it Thursday? Something is Thursday. If that's on the calendar, that's what it is. And we are also going to have, that's very good news. The other class that we're going to have next month is data visualization. Joel is going to teach us data visualization with Dash. Dash is a tool to create dashboards with Python. So it's going to be good as well. We don't know the date yet. Right, coming back here. Okay, so here, what are the information that we have? We have the user, product, gender, age. So each row is one purchase. We have the occupation, city category, how long this person is in the same city, married or not, and the category of the product that this person purchased. So we have three categories. We're going to mostly use category 1. And the purchase value, please, I don't know, forgive me because I don't know the currency of the purchase value. This is not dollars amount, otherwise that's a lot. But imagine that is dollars. Okay. So what we've done here, what we constructed was the idea of how data science can help you solving business questions. And we have gone through 2 algorithms. The first class was descriptive analysis. And with descriptive analysis, we found out that men spend more than women on Black Fridays, at least in this country. And we do have that suburbs, you're going to have people from 55 plus buying different products than young people in other cities. So city matters, age matters, gender matters to classify, to actually predict. So what is going to be the output here? The output is we're going to construct an API that we're not going to do that here, but what would we do? That whenever a person enters our website, this person is going to be classified here due to cookies, to a bunch of things. The companies can see the gender, the age, the occupation, they can have a pretty good idea. The city, definitely, because you have the IP. How many years you are in that city, maybe they have this information. This probably you can figure out as well. And then you can figure out the kind of products that you're going to recommend. So a person entered the website, let's say Bed Bath & Beyond. You know every single this information from this person, what kind of product am I going to recommend? That's the point. How much this person is going to spend. After they click into one product, how much this person is going to spend. That's what we're trying to do here. Questions? No? Okay, so let me go into the data science part. Well, you all have access to this information. So we do have that the average purchase from females is 8,700 and males 9,400. And we have a bunch of descriptive information here. Okay, let me come to this one. Now, what is an algorithm? Algorithm is going to be a model that is going to try to predict something. But how it tries to predict? So, how it reaches into a prediction? It's going to make a guess, and how the machine learns. That's a machine learning class. How the machine learns. The algorithm makes a prediction, it's going to make a mistake. It calculates all the mistakes, add together, this is the cost. And then he tries to improve, trying to minimize the cost. He's going to change the hyperparameters, he's going to change the way he guessed to minimize the cost. So this function here is the cost, and here is the guess that the algorithm is trying to make. And in this case, that's for females. Looking only if the algorithm would only have female information. It's a female. Which would be the best prediction for purchase? It grabs the average of the purchase. 8,700 here, it starts at 5,000, so 8,700. That's how machine learns. It tries something, it's going to make a mistake, it iterates. Try to improve to diminish the cost. Okay? So if we do have something, I like this chart because probably everyone saw this. And everyone knows that the model is going to do this. This case here that I've done, it's just like the machine learning tries to guess this, calculates the mistake, iterates, guess this, guess this, and then he perceives that he has to come here to improve until he finds the optimum spot, the optimum prediction. Okay. Another important information regarding machine learning. So this, all this we've seen before. I'm just going through because those are key information. We're going to later just to do that split, train test split, etc. Because we're going to do this every single time. It's going to get boring. Okay, but how the algorithm does this? We have to train the algorithm. We have a database. So do we feed the whole database for the algorithm to train? No. What we do, we feed a chunk of it, and we call it training set. So the algorithm is going to do this. He's going to try to do a bunch of predictions, and he finds the best one. Now, as we don't know what's happening inside, it might be the case that he does this. My question is this a good model? Is this a good model? No. This is the case that the algorithm is overfitted. It goes very well in the database. But if it tries to figure out a different point, it doesn't have it cannot generalize well. So he's going to make a huge mistake here. So what we try to do is to balance this. And how do we do that? We train the algorithm into one chunk of the database called train, and then we compare, we put the model into test, trying to predict the test database. So we have our whole data. We split, usually it's 20% for test and 80% for training. The algorithm trains here. It tries to grab every single information. After the algorithm is trained, we put it to test. We predict with these values here, and we see how the algorithm performs. Now, let's say that the algorithm had an accuracy of 95% on the training. 95%. And on the test set, it had 60%. Is this algorithm behaving well or not? What do you think? No, because he is capturing a lot of things here that when he puts into the test, he's not capturing. This means that he's overfitting a little bit, although he has a good result here. So what do? We try to make the algorithm less complicated. he doesn't have a lot of degrees of freedom to search for every single nuance. He is more simple. So usually what happens is in the second round, you're going to have here, let's say 87%, and here is going to improve to 64%. So it performs worse here, but better on your test set. Whenever you put this model to a live production, you're going to have a better performance. And of course, the goal is to balance this. Another question. If we have here 70% and here 70%, the model is well balanced. That's good. That's what this model could, the most of this model that it could capture from the database, this specific model. So we're going to see that we're going to have better models, but we're going to get that later. Now, the true question as a data scientist or as a data scientist project manager, you have to know beforehand this number, the accuracy that you're getting nowadays. If your accuracy that you're getting nowadays is 50%, you improved. If it's 80%, the algorithm is worth it. So that's you have whenever so that the class here is AI for business, and it's always how you put this into implementation. That's the question. How you're going to put this. When you're going to decide if the algorithm is good or not. So this is how you tune your algorithm, and you have to compare with what you're doing right now. But we have more things on this, but let's move forward. Because it's, okay, I have 8 minutes. All right, let me run a few cells here. So I'm using this model. I'm importing here that's a random forest and decision tree. Decision tree is, everyone knows, or at least everyone has a very good intuition. You're going to have the columns, the axis, what we call axis, the characteristics of the person, and you're going to make a decision. You have steps to make a decision, to make a prediction. So in this case, the algorithm trained found out that gender was the best place to split first to make decision, if it is a male or a female. So this is what trees look like. Decision trees look like. Now, second, city category, and we end up here because in this model we are only using a gender and city category to make the prediction. Okay. Now we're going to go through 2 other models today that I don't believe that we haven't done before. The second one is random forest. So this is a decision tree. A random forest is a bunch of trees. So you do a bunch of trees, and you grab the database, you grab chunks of the database, randomly chosen, and you fit a decision tree. You do that 100 of times, and you get the 100 results. Now it's all a matter of making the average or choosing the highest one, the largest count. You have some decision process to choose what is the prediction. So random forest, it's a bunch of trees. Simple. Let me erase this.
Quick question. What's the meaning of this less than equal, 0.5? I mean, each of them has this.
No, it's because it's binary. So if we were to have some continuous variable, not continuous, but let's say age, 1, 2, 3, 4, 5, 6, 7, you would have here the decision of if the age is higher than 33 or lower than 33. Basically, here, it's because when we put the database, instead of having males or females, we put this variable gender into categorical variables, dummy variables. So you're going to have gender F and gender X in our database. And they're going to have zeros and ones. In this case, gender F is 1, if gender F female is 1. And gender F equals 0 is male.
Yeah, I would
So-
guess. I
So
would
the
guess.
decision here is true or false. So that's it's below 1 or higher than 1. That's the variable. Now, let me show you something. Oh, I told you about their class. This is Joel, who's going to teach Dash.
Am I doing it myself? Or when does it start?
Next week.
You're kidding.
I'm going to teach the first time. Okay, if we were to have a continuous variable, let's say age 1, 2, 3, 4, 5 until 100, we could end up with a tree like this. Plus 33, which is the same example. If this is lower than let's put false. From 0 to 32, and true from 33 above. Here, the second node, now you only have people above 33. The second node, let's say that we have gender. We could have female, yes or no, true or false? True, false. Female. And here, so once we look into our data sets and we have only people above 33 years old, the second node that it chose to split is gender. It might be that it happens that it is lower than so it is 15. Yes, and only here it splits gender. How the decision of what is going to be the criteria to split, how does that happen? Basically, the algorithm looks into our database, and he tries to split in every single possible way, once, and sees the result. The one who grabs the most variance is the chosen one. So variance is information. If we were to have something like this, the algorithm would be very simple. How to make a prediction would be very simple. You basically would only need one dimension. If we have something with a higher variance, this is more complex. So every single time, what this algorithm does is find the point of the splitting that he's going to grab the most variance. So he looks into every single age and every single gender, every single city, and decided that 33 is the split that he's going to capture the most variance. Then, for the database of those above 33, he does the same thing, and sees that female is the one who grabs most variance. This side, below 33, what grabs most variance is age, 15. So that's how the algorithm makes this decision, how to split the tree. Why I've chosen decision tree to start this machine learning 101. Because one very hard thing that we have, that we face as data scientists, is how to explain to the client, and the client might be your manager, your director, etc., is how did the algorithm came up with that number? And usually decision tree is the only one where you will be able to see the choice that the algorithm made to split. But the rest, everyone here probably heard that machine learning algorithms are a black box. So that's why, as a consultant, and I tell this to everyone, always do a decision tree. Always present a decision tree, because this will make much easier to, and then we're going to do that. The accuracy is not that high. In this case, it's super high. But later we're going to improve. But it's going to make it much more simple for us to explain what the algorithm, how the algorithm is thinking. It might not be exactly like this, but he's splitting, and you see, look, we've done this, that's how it's splitted, that's the accuracy. But we also used deep learning, and instead of 40%, we got 95%. And then I said, oh, okay. Yes, please.
So in the example you've got on the screen and in your example over there, you've got always a binary split. It's either left or right. But you could, for example, split your example 0 to 15 if it's a continuous scale, 0 to 15, 15 to 33, 33 and above, right? Do you ever get these three-way splits or not?
You can choose. Those are hyperparameters that actually you can choose. Usually, yeah, so 3, 4, 5, but you're going to see that this algorithm is not going to perform that well. This is for visualization, something beautiful. Of course, we have to get rid of these big numbers, but we can make this nice. So it's all about understanding what's happening in the decision making. We do have the hyperparameters. Let me show you here every single. No, that's another huge bit. Oh, by the way, for those who haven't heard that before, scikit-learn. That's the package for machine learning that exists. That's the best one. That's in Python, and it's very standard. You're going to see that we're going to go through different algorithms, but the way that we code is almost exactly the same. So check this. It's very important. Let's see. Okay. So we do have here the criteria that you're going to use. The criteria is the values that you grab. In this case, the default one is J. That's the one that we are using. Splitter best, maximum depth. When do you decide to stop splitting? So you have that as well. Mean sample split, 2. Mean sample leaf, 1. Fractional leaf, 0. I have a bunch of things here to actually tweak. And of course, everything that you change, you're going to get different results. And in the end, they assign a little bit of an art and a lot of effort. There are those who claim that machine learning is like, you have a bunch of people doing it. That's why you always there's always going to appear some solution, because you're going to change every single detail. I'm going to change this. There's not a huge science behind it. For some, there are. Yes, please.
So this question about the decision tree. So the outcome variable or even variable, can it be like multi-dimensional? Can I have like, so here the outcome I understand is the sales or the purchase price or something like that. But can it be like multiple variables?
Look, that's a very good question. I haven't seen that, and thinking about the way that this optimizes as a cost function. What I would do right now, it might, probably there's a better solution for this, but I would, let's say that I want to predict purchasing quantity. So I would make purchasing quantity one variable. I would somehow put them together, multiplication. I would put some weights 1 on 1, and I would have one y, but usually it's because you're asking if the y can be multiple dimension, doubles of n dimension. I haven't seen that because my problem is whenever we're trying to make the cost function, how to minimize that.
Covariance matrix.
I have to check that for decision trees. I've never seen. Okay, moving forward. All right, so we do have, so what I did here, you're going to see this in the notebook. I start to add different axes. So now we have gender, city categories, and age. And we do have our prediction. And whenever we check the result, how good this model is, we have a 0.01 R squared, which in English is terrible. It's very bad. It's very bad. This has to be close to 1. This number. A good number would be, well, for a financial market, it's until, I don't know, 4%, you're going to be in a good shape. If you get higher than 4% financial markets, because you're wrong. There's not such I think that's going to improve that much. Okay, moving forward. Now I'm going to enter this class. Questions so far? Feel free to ask any question. Yes.
So how much data and samples do you need to start to get valid?
That's a very good question. The size of your data is going to depend on how many characteristics you have. So x's. For every single x that you include, it's 1 dimension. This means that you're going to get a lot more data. So that's the dimension. Whenever you're trying to fit another dimension to make the prediction, you're going to need more data to capture the nuances of that new feature. But of course, it improves if you have more data. So it's going to depend. In this case, we're going to have a pretty good result. We have over 5,000. Yes. 550,000. So we have a lot of data. We have a lot of information. Let's say that if you have lower than 5,000, you're going to get something out there. Higher than 5,000, it's better. And of course, that's very important. Descriptive analysis is very important. Usually it's 90% of the work. Machine learning is going to give you new information. But the information that you need to understand the business is on the descriptive analysis. And if you have a low size database, you're going to be able to infer some things from it. Or at least to raise some questions that you're going to get more data later. Yes, please.
Another question. When you do predictions, right, you typically pass array all zeros, right? 1 or 3 or 9, whatever dimensions we have, right? The question is, what's the meaning of those zeros? I mean, what if you put 1 in some place?
That's a very good question. Let me show you what I'm doing here. Okay, let me. So whenever I do this, PD pandas, it did not get dummies, and I parse my database. Beforehand, I had a column called gender, F and S. But machine learning doesn't understand F or S. It understands numbers. So it transforms to ones or zeros. Now, so when I do the machine learning algorithm, if I parse these two columns here, gender F or gender M, one is the exactly the opposite of the other. So gender F, we're going to have 1 for female and 0 for male. While gender M, we're going to have 0 for female and 1 for male. It's exactly the opposite. What we do, we hide one part. So that's why whenever I do, so here I've trained, so now I have gender, city, category, and purchase. Purchase is the Y, what I'm trying to predict. Let me run this, let's see. Okay. So we do have gender F, gender M, city category A, B, and C. When I do my training set, when I do my train test split, I'm only grabbing gender F and leaving aside gender M, getting B and C. So when I put here 1, 0, 0, it means 1 for gender F. This means it's a female. 0 for city category B and 0 for category C. This means that it is city A. Good. And then, so I'm trying to predict a female in city A, how much will she spend? That's the prediction here. Moving forward, questions? Feel free to ask. Don't worry. Yes, please.
If you go back to the gender which you showed, right? The 0 and 1, the binary which you assigned.
Just gender.
Yeah, and if you come to the decision tree at the bottom.
Which?
We assign the 0 and 1 for the gender F and gender M. So 0 is like, and if you come back to the decision tree, how it's related to that.
Go back there.
Yeah, right here.
Here. Right here, okay?
No, a little below.
Here.
Yeah, in the tree. How you're assigning that?
How am I?
How are you using that 0 and 1 here in the binary here?
Yeah, so gender F, every time as you have ones or zeros, you're going to have a decision boundary. This is always a decision boundary. This would be with 33 plus. So if it is below or higher than 0.5, which means if it is 0 or 1, that's the decision boundary that it makes. If city C is lower than 0.5, this means that is 0. If it is higher than 0.5, it's 1.
Fine, yeah, but how do you see that in this tree? Because at the top there is true and false. You know, okay, this is female, this is male.
Yeah.
But below, when you go to the next row, there is no true or false. So, like this dark brown, is it true or is it false?
No, that changed. It changed from gender to category there.
Okay, category, fine.
Yeah,
But-
you take the category, yeah.
But what does it mean? On the third row, right? The dark
Here.
brown. Yes.
In this case here, it looked into this and said, look, if 0 is 1, you get the result. Because you only have gender and city category, you get a result. If city is 0, it could be A or B. Now it reaches another decision, A or B. Now this case is B, and this case is A. So here you go 0, 0, 0, here you go 1, 1, 1, I think.
Just a big and statement.
Does that make sense?
Female and city category 0 and, well, I don't know, the second city category 0. I wasn't paying attention, sorry. But MSC, whatever it says here. What's MSC?
Mean square error. So that's the error that is making a lot.
Okay.
Second is C, right? C less than 0.5, meaning the city C is like
You're looking if the person lives in the CDC.
big difference.
It is, yes. It shows as the second information that you have to split.
And then the other cities.
Yes. Okay. Right. Now, so we do add some other categories, but I'm going to pass into that. You can check here a more bigger example. So again, when we include age, still gender, the first one, then C is the second one, and then if it is CDC, that's one, you come here, gender, age, 0 to 17, that's where it chose to split, while here, age 18 to 25 was the chosen one. All right, now let's move forward.
Just asking one more question. So on with random forest, so what it's doing is
Decision tree.
yeah, but so in random forest version, so it's just taking samples of data, it takes different cuts of it and then makes its own decision trees and then determines which one it's randomly, and then pick which one's the best.
Yes. Let's say that in this case, as we're trying to predict, purchase, which is a continuous value, it's going to take the average of the predictions. So what it does, it's going to make the first decision tree. One person entered, they did the classification of the person, reached the decision. It's going to output a prediction of the purchase. The second one again, the third one again, 100, and then it takes the average and so forth. That's the good one. Why is that? Because whenever you sample, there's a little bit of sampling theory. You have your database. Now, whenever you sample, and that's the bootstrap strategy. If you grab a sample of your database, you're trying to, a lot of samples, basically you're trying to mimic the distribution of the whole population. So you diminish the variance, the bias that big data that you have is going to have. That's the, all right. So, okay, now the class starts here at data 4. Data 4, I'm going to use every single column. Yes. So, I do some cleaning here of the data, stay in current city. Instead of 4 plus, I'm going to put 4. This means that this is going to become numerical. So it had 0, 1, 2, 3, 4 plus. So the computer understands this as a string. When I change this to 4, it's going to understand as it's going to be there. I'm not going to split this into categories, increasing my dimension. I dropped the user ID and product ID because this doesn't matter. So I transform, in this case, I use this LE. LE is label encoder. Instead of splitting into two columns, male or female, and putting ones or zeros. That's what it does. Okay? And that's the database that they have. Okay, I'm going to use every single column that we have in our database to try to make the prediction of the purchase. One other thing that I do here, I did this here, in this case, let me show you. But this is an improvement that can be made. That's not the best way to do it. I did this because we're not going to gain any. We're going to gain a little bit of performance, but I did this. Drop MA. Every single row that has a non-information, I dropped. This is an issue because got purchased 2 or 3. Oh, let me change this quickly. Because these 2 columns here, product category 2 and product category 3, they are most MAs. So my resulting data set has only 100,000 rows, which is pretty good. So I did that. The ideal would be not to do that. Who here wants me to change this now? Much better. Because I've dropped all the NAs and now I still have 550,000. It's a little bit less than what I used to have, but not much better. So thank you very much. Okay, so now we do have our database. What we're going to do next step is, okay, define our X and our Y. I haven't said anything about X's and Y's. Who here has doubt about that? And no, don't worry. Just know. What is an X and what is an Y in my database for machine learning? And move on. If someone has doubt on that, do this. Okay, so we do have 7 columns for X and 550,000 rows. Right now I'm going to run the train test split. So I'm going to split between train tests, X for train, X test, Y train, and Y test. And I'm choosing 30% for tests, 70% for training. I have a lot of data. Now I chose 80% for training. So I do some explanation, and now let's do the decision tree. Don't look at the results. Don't look at it. Okay. Now we're getting somewhere. Now we have a prediction model, right? Let's see something here. Oh, I'm not curious. I haven't done that. I should have done that before. Before I run this, okay, what am I trying to do here? Who can answer me this? I just included this line here. What am I trying to do here? What is the thing that I'm trying to compare to see if how it's going to behave? So before I had this result as the score of my model. So that's the performance of my model. It's good, right? But how do you know that it is good? Because beforehand I put it here 95% and 65%, and you said no, that's not good. So actually, what I have to do is make a comparison between when I use the training set to see what I got from the training set and what I got from the test set. Now let's see if this model is balanced or not. It is. All right. That's a very good model. We're proud of ourselves. But that's decision tree. No, but it's going to improve. Now let's do the same thing for random forest. Now comes sklearn. Now comes the beauty of sklearn. Once you have the data set ready, weren't you surprised by how many lines? Let's see how many lines. Train a model. How many lines was necessary to train a model once the data set is ready? Isn't that fantastic? Just 2. Right? I think that's amazing. But even more, I had a model, decision tree. Now I want to do random forest. Again, that's it. Just change this guy here. That's simple. Is that simple? Now let me do this again. So we can see. Random forest regression 1. And this is a regression because we are trying to predict a continuous variable. Okay, so before, of course, this is taking a little bit longer, but it went. Well, the improvement wasn't that big. Probably because we have a bunch of data, a lot of data. But it was better. Now it takes a while to run because it's running a lot of decision trees.
So I understand the difference between the test and the train. What's the difference, though, between the Y and the X? I don't get that.
Very good question. Good. The Y is the thing that I'm trying to predict. The X is the characteristics
Oh,
that I use to predict.
it's the predictor. Oh, and the outcome.
Y the outcome.
Okay. Okay. Thank you.
Is everybody good with that? Because I haven't talked about X and Y. It's going to be very important for machine learning 102.
It's the dependent versus the independent variables.
Spoken like a true statistician.
Yeah. All right. Okay. No questions here now. Regression, scalar, demo first. Okay, and estimators, criterion, max depth, where's the? What am I doing now? Question for you. I put it on 100 in front of me. Before I saw that the default value for n estimators is 10. This means that the random forest is composed of 10 decision trees. So now I said, okay, it had the similar result. Let's increase this to 100. What is the downside of it? It's going to take a while. That's a huge downside. That's like 100. It's going to take a while. But so far, no questions, right?
Okay, so I've got a question.
Yes, please.
Since we're waiting anyway, what does reshape do? You've got a command here, reshape.
Yeah, I put this reshape later. I found out that for Y, I don't think that is going to be necessary. I've done a different. At first, I did a transformation that did the reshape, but later it wasn't necessary anymore. The reshape, you're going to see that whenever you put shape of a given object, you're going to get just like dimensions. You're going to get the dimensions. But there are some objects that they don't have dimensions, like arrays. So if you have a NumPy array, you're going to have dimensions. But there are some other objects that it doesn't understand as a dimension. It's just a bunch of numbers. Now, whenever you put reshape, you're putting this into one shape that you want. This is going to become very common whenever we enter into deep learning, because it's a matrix operation. We're going to play a little bit with those matrix sizes. So tensors are like matrices of n dimensions, and we're going to play with this. That's what it is. Did you read? It's applied. Okay, yeah. It didn't make it. But sometimes it works. But that's the point of hyperparameters. It's not, you never know what you're going to get. And in this case, you take the average, so you're not going to overfit. Yes, please.
So in this random forest algorithm, how do you control the overlaps between the trees?
You don't.
You don't.
The control is based on the random sample that you do of the database. Whenever you do, how does the trees get different? Because they look into different chunks of the database. So let's say that I have a decision tree. I'm going to put in, this is one of the hyperparameters that you can tune. How many samples you want to collect for every single tree. So let's say that I put 30% of my database. So I randomly select 30%, make a decision tree, get a result. Another 30%, get a decision tree, result. And you're going to have overlaps, but there's no problem with that if you do it randomly.
Same statement for coverage as well, right? You cannot guarantee that the whole database will be covered.
It might be the case that you're not going to get the whole database. It might be the case. By some crazy randomness of life, it might be the case that you're going to get always the same chunk. But if you do it randomly, and a lot of times, you're good. That's why 10 is not a very good number. Because 10 is not a, you gotta have 10 different samples, is always so well, this is being recorded. I'm going to pretend that I haven't said that, but over 30. Whenever you're trying to sample something, over 30. But that's not correct. I have a friend who I had a doubt regarding time series. And I said, but I don't know how to build that. And then he said, look, there's time series and there's streetwise time series. Streetwise time series, you do this. Over 30, that's streetwise. Okay, now we come to the new guy that I haven't spoken before. I have said something regarding ensemble models. And I'm bringing one ensemble model. What are ensemble models? Basically, what they do is you have a bunch of models together. Several models together, and they're going to make a prediction. How does that work? You have the first model. This model is going to make a mistake. Instead of collecting, adding up to the cost function and try to minimize that, you have a second model that are going to grab the mistakes and run a model. It is going to be, it might be completely different. It's not like a decision tree, then you have a decision tree, then you have a no. It might be a different thing. So those are ensemble models. They are combined. And this is one of the, this one is very good, gradient boosting regressor. So this, okay, again, 100. Let me draw something. So we had gender, we had age, we had city, and we had purchase. Age. See, let's say that we only have A and B. A, B, B. Purchase. We're going to put this, everything that we put in is random, so we're not going to random any conclusion from here. But it's just to show how this works. let's say 100, minus 110, 120. It's updated, so, yeah. Right? Okay. What this model does is, this specific one, very specific, what it does is, first, the first prediction that it makes is the average of the values. So in our case, we have 200, 340, one side of the foot, 340 divided by 5, 60. 8. Right. 340 divided by 5. Good. Okay, 68. So we're going to have our first pseudo error. So I'm going to put here P error. 68. You see, that's why we have to 42, have a good number. 22, 42, 52, 60. There's nothing better. That's why. 16.8. Okay. So our first and 68 is our first value. Okay. Now, what this model does, this is some model does. It makes the prediction. It creates a decision tree of one node with this and trying to predict this. It makes a decision tree to predict this, the mistakes. And he's going to render some results. Let's say he's predicting 25, 18, etc. So the full prediction of the second model is the prediction of this plus 68. Correct? Okay, who here didn't understand this one? Okay, go to. Let me open Excel because here's something else. So we have gender, age, and we have city. We're going to put age from 50 to 70, okay? And 66, 62, and finally 57. And now I'm going to have all right. Okay, and this guy 100, 120, 70, 55, 130. Okay. So the gradient boosting, what it does. First prediction. Average. This one. Okay. That's the first prediction. For every single person, it predicts the average. Of course, it's going to make mistakes. error 1. So this guy minus this guy. Okay, yeah. So those are the errors, correct? Now, what it does is it's going to have a second problem. The second problem is this guy and this guy. Now, he's going to, like we were doing, he's going to make a decision tree and try to predict this. So he's going to train here, and he's going to make a prediction here. Trying to figure out these crazy numbers. So this is model 2. Model 1 is the average. Model 2 is one decision tree to make this prediction. Let's suppose that it predicts 1 minus 10 minus 3 2 10 20 minus 5 and minus 12. So the model now is making error 2. So, by the way, let's not look into this. So what is the value that the model is predicting now? So this was the first prediction. Now the second prediction is going to be equal. The first prediction, yes, the first prediction plus right here. The prediction that he made. For the errors, there are residuals. Whenever you're predicting a residual, you're predicting a very small, tiny thing. So you add up to the first prediction that you made. And now you have your whole prediction. So imagine that the ensemble model, it has layers of models. The first layer is just the average. If you look into just the first layer, you're going to make a prediction of the average. If you look into the second layer, it's the average plus the prediction of the first errors. The third layer is the prediction of the average plus the first errors plus the prediction of the second errors, and so on. You can have this as big as you want, and of course you're going to overfit at some point, and so you have to make this. Remember that I said that whenever you overfit, you make the model simpler. So making the model simpler is not going into a lot of layers. But look into this. If now the second prediction, and but I did this by hand. No, I'm not going to say that because, but the second prediction is closer to the value that you want to predict, and it improves the model. And you have if you have the third prediction, it improves a little bit more, and the fourth, and so on. If you overfit, you diminish the number of layers of your ensemble model. How clear is this? Who here still have some question regarding how this works? And please be honest. Okay. Let me see if this works.
And you said this was the gradient boosting model.
Yes. Gradient boosting regressors. Let me see if we can do this. Loss learning rates, estimators. Let's see if this goes correct. Let's go with the change. Just a simple one. Okay, yes, the test. Yeah, so probably it's going to the second layer already. Otherwise, this will be only the same numbers because this will be the average. What I tried to do here is to put 1 as the layer. But actually, this probably is one, the first decision tree. So this guy here is taking the average of everyone. In my test set, I have 110,000 rows. 20% of the data set that I have, that's 550,000. And it takes the average. I'm going to say the same thing that I'm going to see a difference. This one. Layer 0. Layer 1. This model here has only 2 layers. This 0, that is the average. So for every guy that I have in my test data sets, not that have. One, two, three, four, five, six, seven columns. So these numbers here, I did the normalization of the columns that I had. So remember that I had seven columns in my X. This guy here, the first layer, is going to take the average of the purchase value of everyone and put this as the prediction of every single row here. Of course, that is going to make a mistake. So far, this first model, is it clear or not? More or less. Remember that I had age. Let's pretend that I only have age. And I have here and 20, 30 years old, and I know the purchase value. That is going to be 100, 110, and 120. That's my data set. Now I'm on my website, and all of a sudden appears a person. And I know that this person is 23 years old. What is the prediction that I'm going to input here? If I'm using only the layer 0 of this one.
Average.
The average of these guys, which would be 110. And if a person of 77 years appears, 110. And for everyone, I'm going to make it the prediction of 110. That's the first layer. And I could just simply go home. But remember, at the beginning of our class, we were making a prediction like this, and we had a terrible R-square. How does it improve? It's going to say, look, I'm going to run a random forest, not at this, the purchase value, but actually, it's not the decision tree, the first decision tree. The goal is not to make the prediction of the value, but actually is to improve my first model. I want to make the prediction of how wrong my first model was. So what am I going to use as a y? Not the purchase value, but actually the mistake that I made, which was -10, 0, 10. So now I'm going to run a decision tree to actually try to capture where my first model went wrong. And I could see that this guy here finishes at this level because I put it this way. So what do I have? I have the first model that makes the prediction, and the second one that helps me getting things a little bit more correct. And I could put a second one, a third, a fourth, and try to help these predictions that I'm making by always looking at the error. So this is the error of the first model. The second model is going to make an error as well. I can embed a third one to help him. I can embed a fourth one, and so on.
So the number of layers is the end estimator?
Yes,
Each layer is different.
I think so. Sorry?
Each layer will be a different model.
It's a different one, yes.
How do we know which model you use each layer?
So each layer, in this case, is going to be a decision tree. In this case.
The same model we are using again and again.
Now, it's always a decision tree, but you're going to try to predict different things. So the model itself is different, but the algorithm is the same. It's decision trees. I'm going to put a bunch of decision trees, but this does this gradient boosting regressor does this automatically for you. Basically, you just have to put here 100 and it's going to take a while because it's filling a lot of things. Is it there now?
Did you already talk about what the second stage does, the boosting piece? I'm sorry, wasn't I don't know if you talked about it. I want to repeat what you already said. So the boosting, I'll just say it, the boosting piece, right? So tree one, simple split, error, right? You have residual, actual minus predicted, or vice versa. The second tree, the dependent variable is the error. You do it again, get the error from the second tree. The third tree, blah, 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 keeps going. Then you just add it all up. Yeah, that's what it's actually doing. And it's one of the best models out there.
That's a very good one. Very good one. Now, yes.
Yeah, before, as a concept, kind of concept, I read that this model used to beat neural networks.
Yes.
Still neural networks got really, really good. This was always the best.
Definitely, this is a very good one. People here who worked with this a long time. The beauty of sklearn is that there's a way to put this to predict. Well, the beauty of sklearn is that you have something called pipeline. It's an object. And pipeline you've seen that to put a model, it's very simple, right? Just put this here. Pipeline. You put models one after another. And you can create your own type of ensemble model, which makes it even more powerful. So instead of looking into every single model that you create, you tweak the model, etc., you can actually increase the number of models that you're using to create. Whenever you put into a pipeline, it's going to use the first one to make the prediction, the second one to help the first one, the third one to help the second one to help the first one, and so on. And this actually, algorithmically speaking, is very easy to build. It's a little bit hard. It's not easy, but for the power that it renders, it's easy. And this is something that sklearn can do, and it's pretty hard to do in other frameworks, like R.
No.
Not so.
Great.
Yeah.
There's a dispute between Python and R. So,
No dispute. More powerful, easier.
okay, guys. Now that the first half hour of the class is gone, let's do the hands-on part. I'll just okay, questions? I always like to ask, who here learned something new? Who here thought that this was not a waste of time? Who here liked the And the funny thing is that there are a few people who doesn't raise their hands. And then I look at the person. Yes, please.
The latest one.
Sorry?
So what are the scores?
Still. It's here. Now it's a small guy. Put this here. Yes, so it's worse than the rest. This probably we're feeding decision trees here, and we do have a lot of them.
How do we improve this?
They tend to converge.
How do we improve this?
How do we
Improve it.
improve the code? That's why I created the X train and Y train and test. It is well balanced. So using this algorithm is going to be a little bit hard to improve this guy here. What this means is, given the complexity of your algorithm, you're extracting the maximum of it. But in the training set, it hasn't reached the 100%. But of course, that the 100% is not the boundary. The boundary is what is the maximum accuracy you can grab from these data sets. Well, definitely it's not 100%, but if you reach a situation like this, you'll have to be able to make your model to grab more information, to become more complex. How do you do that? Increase the number of layers. It is a decision tree that you put after, so increase the way that the decision tree grabs information, the maximum depth of the decision tree, things like that you can use to improve. But bottom line is, make it more complex, so it can grab more information. question?
So let's take random forest as an example. If I look at the documentation here, there's about 20 or so parameters for fitting, right? So how do I choose? How do I optimize now, right? I mean, so I could, number of estimators, I could choose 200 or 500 or 1,000, or perhaps I could run a whole variety of different things, and I can choose the next parameter, criterion, Gini, whatever that is, you know. So how do I, what's the best approach to optimizing, getting the best fit, the best results with all these different parameters that could be changed?
That's a very good question. And the answer for that is you have to have experience with a given model, with the models, and the business case. Now, different models have different hyperparameters. How a given hyperparameter change your model, that's very unique for the hyperparameters. Whenever you get in your toolbar 5 models, 4 or 5 models that you've done a lot of these things, and at first you're going kind of doing trial and error, and then you're going to start to, just like I said, look, you have to make it more deep. The decision tree, you need more layers, because I know that these things increase complexity. You have to figure out if you have to increase complexity, decrease complexity. And now from there, every single thing there, it's going to increase or decrease complexity. The Gini index, for example, you have Gini index, you have entropy, is another measure. Maybe for one case, you're going to use Gini, the other, you're going to use entropy. And that's the downside of machine learning. Because this part is a lot of kind of a trial and error. Because of course you're not going to say, oh, what is the maximum, the optimal depth of the decision tree? You don't know that. And you'll know that you have to increase. Maybe you increase them by 5 and see the results. And then there's no exact science on that. What you can do is grid search. If you do have enough computing power, if you have time, and it's going to be a composition of both, you do grid search, and then you're going to find out. Usually that's what people do.
So start perhaps by doing a grid search or a defined set of values, and then gradually over time you get a feeling for the best way of modeling. It's more of an art, perhaps.
You can call it an art, you can call it trial and error. It's
an experience. Right?
But definitely it's not science. If let's say that you double the depth, this means that you're going to reach it's going to make 3 times. No, there's no rule about that. It's going to depend on the database. That's the downside. Okay. Next week, we're going to have 2 classes again. One regarding data visualization, and the other on machine learning 102. I don't think that we're going to have Python classes next month. We did with Bloomberg this month, and I believe that they're going to continue to teach here. I don't know when they're going to start. I know that someone is going to give a GitHub class. That's interesting. It's a guy from the university, a student from Princeton University. I don't know who, but Kelsey, who is the director of the next center. What else? On the 2nd, November, it is a Saturday. I'm going to do a workshop called AI for Decision Makers. Oh, I believe it's going to be around 4 hours. And we're going to have some canvas, and the idea is for you to bring issues, to bring things that you believe that it might be improved with AI. We're going to go through some cases that AI improved in companies. and where everyone is going to fill up a canvas to try to figure out how to embed AI into your company or into your sector, department, etc. And how to scale from there. That points. What else?
How come I can't find Machine Learning 102 on the Medium? Is it something I'm missing?
It's because the guy responsible for the meetup hasn't posted that yet.
Very good, thank you.
Talk to me. Okay, I'm going to put that. So we were doing this subscription on the Google Sheets, but I believe that we've converged into a good number of people. We're having a problem with a lot of people too. And which is not a problem, and that's why we started the YouTube Lives. Good news, that now we have right now a YouTube Live, you can watch this at home with popcorn. Of course, here is more fun or not.
Are you planning to keep doing that?
Yeah. We have natural language processing class tomorrow. And it's going to be the last one of the series. We do monthly series. October, I'm going to travel, so Adam is going to teach machine learning 102. George is going to teach Dash. And it's very serious about that.
What night are we gonna do it?
You're going to decide. You're going to teach it. I have talked to you guys.
We haven't decided, no.
I have. We have letters.
Okay, it would just be nice to know.
And I think that's it.
Prior sessions, can we access the prior
I
session?
think we are. That's the first time that I say, look at how happy I am this. Yes, because we recorded, but we haven't uploaded. But we have those sessions. They are all, unfortunately, they are on my YouTube channel. So Vinicius Pantoja on YouTube. I'm going to put that on Princeton School of AI channel. I don't have the time to do that. It takes a long time to upload the video. But I have thousands of followers, probably 5. And I think, what else?
I think it would be a good idea to put the link to your channel up on the screen, just so that people here can know where to go in the
That's a very
meantime.
good point. That's a very
I think that would be helpful.
good point. Here, you're going to have a bunch of things about Flamengo, my soccer team. Let's see what comes up. Okay, this is the guy. Oh, 9 subscribers. All right, we're going to have the party. If we reach 10, we're going to throw a party. Elements for everyone. I'm just kidding. Guys, thank you very much.
Thank
you.
So, okay, good. So, you go.
Which slide is